So ordered pairs that you believe would be a part of that. Okay. Obviously, the other side of that paper will be part of your homework for tonight. And we'll talk about that in a minute. I'm sorry? I'm not quite sure what you would solve. So you're looking for things that would be a part of that graph. So you should be picking values of x. If you wanted to graph it, if you needed an ordered pair, you'd pick a value of x, plug it in, get its corresponding y value, take that y value, you'd have an ordered pair. Right? Can't treat this the same way that I would treat a linear graph, a straight line, because there is no such thing as a slope here, so I can't go that route. What values should I choose if I want to graph? That's kind of what you should be thinking. So obviously, this is a little bit of a setup, right? Like what what are you trying to do? What do we know at this point? I see a lot of you guys starting the same way, which is a great idea. Talk about what that is here momentarily. If I was going to graph a straight line, how many points would I need to have? 2, right? Is 2 going to be enough in this situation? We know what the picture is going to look like. I mean, I think generally in one of 2 directions, it's going to be that U kind of shaped parabola, whether it's facing up or down. But then what? I mean, I'll tell you here, my table has 5 openings on it. So, kind of thinking along those lines, maybe. Yes, ma'am. What's up? Yeah. What you got? You did not copy that correctly. Look up there. What's missing? Yeah, which means there's a negative there, and then 1 there, and now there's not 1 there.
But did we reduce this number then?
Well, this number's not going to be that now that it's not a -2. You know what I mean?
Mm-hmm.
So watch, if you hit on this calculator second and enter and get it all back, then you can just come over here and take that out. Take that one out. Oops. Get out of here. Take that away. But you need a negative in front of that whole thing. So there's the number that goes in the middle. What about it?
Do we make one?
Yeah, we'll talk about that. But yes, you will need one for sure.
So I don't remember how to find it. So I have like
That is your x.
that.
That is your y.
Oh, so okay.
Yeah, so look, this thing originally says it's x, so that is your x value.
that?
You plugged it in.
Find your y.
That's your
Oh.
y value.
So that'd be right.
It would be.
Oh, cool.
It would be.
I don't understand what you do after
What do you do with that? Yeah. What is that ordered pair? That's what you need to be thinking about. It's your okay. It does create your line of symmetry. That's good. Yeah. Then what? The values that you need in there are your B value and your A value. What's B up there? So you need opposite of B over 2 times A. Okay. So, number one, I see a lot of you guys making a good start. Some of you guys starting to create ordered pairs that potentially could go into this. Yes, here, but not there. But we'll talk about where we need to go with that. Yes. A lot of you guys started by trying to do what? What did you try to do first, Faith? So we tried to use that axis of symmetry, right? That opposite of B over 2 times A. What is when I plug that in, when I use the opposite of B over 2 times A, so let's put it over here. Opposite of B over 2 times A. What am I getting there? What numbers am I putting in? What result am I getting out of that? What am I trying to say? What is that ordered pair that's being created? Where do I start with that? What's my B value? Let's start there. What is it, Hunter? 12. So I'm going to put in, what'd you say? I'm going to put in negative 12. And then divide that by 2 times A. And A is negative 3. And that gave me an answer of what? Good. Negative 12 over negative 6. So final answer, 2. Okay, great. I know that X has a value of 2. What's the corresponding Y value that goes with it? Connor, what is it? 8. Okay. So I have an ordered pair. 2 and 8. Right? What is that ordered pair? It is maybe it's the highest point. Yeah, no, you're getting there. It's your vertex. Okay. It is definitely your vertex. And at your vertex is created what? What did you just say? Your line of symmetry. Okay. So in my mind, I kind of have to know what this picture is going to look like, even though I don't truly know where it's located at. Would you agree with that statement? I just found the middle of it, the vertex. I know that at that point, I'm going to have this line of symmetry. Did we talk yesterday about knowing the direction of this graph? Sometimes I get confused with how many classes and what. Good, very good, James. So right there, that value tells you which way your graph is going to go. So because that number is negative, my graph is facing which direction? Facing down, like an N. Was that what you said? An N shape? Okay. So because I know that, and I know that this ordered pair right here is my vertex, will that ordered pair be the highest point or will it be the lowest point? Those are your choices. Highest, right? You can almost think about that being at the top, and from that point, everything's just falling down from there. All right. So that's kind of a lot to initially think about as you're picturing what this is going to look like. The next part, though, to this has to be, where do I go from there? Some of you guys had ordered pairs listed all the way down your table. Okay. I think, though, we need to kind of be systematic about what we choose and how we choose it. And that's what we're going to take a look at today. Okay. How does that come into play? So we'll come back and revisit this question in just 1 minute. All right. But that's what we're going to take a look at today. Graphing. All right. Listen, we're not always going to graph by hand. Okay. There are better methods to graphing a quadratic. I'm sure, James, I bet you could tell me a better tool than graphing by hand. I for sure could use Desmos to do this as well, and we will. Don't get me wrong, but I think it's important that you understand how it works before we just go plugging stuff in and watching a picture appear and have no idea why or how it got there. Does that make sense? So I'm not going to do a ton of graphing by hand, like a max of 3, including 1 on your homework. Okay, so but we just I think need to understand how that comes about. So in this section, we're kind of looking at these ideas like can I graph it? What characteristics come from there? This idea of a maximum or minimum. James just talked about that idea. Like when I find that vertex, is it the top or is it the bottom? Those kind of things. And then ultimately, we're going to try to answer a question using this idea that would be it involves a basketball. Of course, that's how I tend to write all my things, I guess. So. Can we analyze these characteristics? And we talked about some characteristics. I'll talk characteristics yesterday. The vertex, the axis of symmetry, the zeros, those kind of things. All right. So, some words we could run across today. Is there anything you see on that list that you do not know? Yes, ma'am. The first one. So, a quadratic function would be anything that's of the form y equals ax squared plus bx plus c. Okay. Anything else on there? The parabola is simply just the graph of that quadratic. We talked about how to find the vertex yesterday. James kind of hit on this idea of a min or a max. We all know what standard form is. Standard form means that we've done what with our function? Yeah, we have simplified it, but it's going to be the way in which we write it. How are we going to write it? We're going to do it how? Highest to lowest. The powers. Very good. Those exponent powers. Okay. Hi.
Is it called quadratic because of the 2?
Yes.
Okay.
Yep. Yeah. Remember when we talked about classifying that word quadratic meant anything raised to the second power, even though a lot of you guys wanted to tell me it was raised to what power? The fourth, right? Okay. And then that axis of symmetry we've talked about as far as that vertical line. All right. So when we talk about a graph, obviously that axis of symmetry formula is where we have to start. And a lot of you guys did that. And in this particular case, we found out that the middle of this graph was going to be located at the ordered pair 2 and 8. But when you create this line of symmetry, you create mirrored options on either side of it, right? Meaning that if you found an ordered pair, let's say over here, you get a freebie on the other side of the line. Where's the ordered pair at on the other side of the line that matches the one that you already know? Like if I know that the ordered pair -1, -1 right here is definitely a part of my graph, what's its mirrored image that I know the result of without having to do any work? Do you understand where I'm going with that? No? Okay. This red dotted line creates symmetry. It creates a reflection from one side to the other. Okay. Anything that I know on this side of the line to the left has to be mirrored on the right side of the line as well. Meaning, if I know this ordered pair right there, then it is 1 unit away from the line of symmetry. That means there has to be one on the other side of the line of symmetry that matches it as well. Okay? So if the ordered pair on the left side is -1 and -1, then this one over here would be -3 and -1. They both have the same result, okay, on opposite sides. That's super helpful in a parabola because it means I don't have to find as many points as I'd originally thought that I had to find. Okay. If we go back to this picture here, I might be better suited to put this ordered pair of 2 and 8 not necessarily in the first spot. Do you know where it would make more sense to put it, Alexis? In the third spot. How come? Because it's the middle, right? And so I actually would like to think about building things around that point and not necessarily starting from that point. What's up?
Oh, I was just gonna say, let me just go. Well, I just did 0 to 4.
Yeah, absolutely. Right? If 2 is my middle number, then let's build around 2. And so 0, 1, and then on the other side, 3 and 4. Symmetry is now created because I found the middle of my graph. Meaning, if I know this answer right there, what else do I know? I know which one? The one that matches on 3. The one that is the exact same distance from the vertex on either side. So if I come over here and graph this, 2 units and 8 units, that point right there. Now your graph only goes to 8, so it's going to be at the very top of yours. Mine goes to 10, so they're just a little bit different. What's up? They equal how much? 5. Okay. So if I plug a 1 into this equation, or I plug a 3 into this equation, Allison's saying I'm going to get the same result. I'm going to get a 5. Is that true? Yes? So if I graph these, 1, 2, 5, there's that one, and that's its match on the other side, right? Because if I think about, there has to be symmetry created right down that line. What's up? You got the next two. Did you plug those values in? Did you plug them both in? Did you? Okay. What'd you get? -4. I'll be honest with you. If I know that 2, 8 is the middle of this graph, like I am certain that it's the middle, I probably wouldn't even plug both those in, to be honest with you. I probably only plug one in. And working smarter instead of harder, I know which one I'd plug in. Do you know which one you'd plug in? Would you plug in the 0? Or would you plug in the 4? Faith? You'd plug in the 4? We're not hanging out. I'd plug in the 0. How come? Yeah. Putting a 0 in there knocks all that out, right? This is gone, and all you're left with is the -4. And if that value is -4, so is its match on the other side. So now 0 and down 2, 3, 4. Now that's 2 units away from the line of symmetry. So the same thing would be true on the other side. And lo and behold, I have my picture. What's up? Hey now, I don't plan on graphing that. Are you going to graph that? -1 and -19? It's moving in the right direction though, right? I mean, at 0 I'm down 4, so my answer to -1 has to be less than 4. -19 is definitely moving that way. What's up?
Okay, but like, so we find the like -4, but how does it match to 4?
We find the -4. How does it match?
For 0, so how does it match for like, how does it match to 4?
Why is this answer and this answer both -4? Because they are both equally distant from the middle. So this blue ordered pair is my vertex. It is the middle. 2 units smaller and 2 units bigger, both are the same distance away from the middle. Therefore, their results will have to be the same because this graph has that symmetrical look to it that goes right through this green dotted line, which was found by using that formula right there. Okay. So when you think about graphing a parabola, where do you have to start? Where do you have to start? You have to start with that axis of symmetry. You have to find your middle. Once you find your middle, then you can build ordered pairs around your middle. Does that make sense? So we're going to try that now, understanding what it is that I want to find. And a lot of you found it, you just didn't know what to do with it, right? So once I find it, then I can build that look. What's up? Stop it. I'm not graphing those. Negative 19, negative 40. What's the next one after that? Like negative 80 something? You think it's worse than that? What's the number? What's the X value you're putting in? Negative 67. All right. Okay. So kind of following through that thought process. And, we used this one here because it worked out. But if you're looking for an ordered pair, using your y-intercept is always probably a nice one because it plugs a 0 in for x. We did that in ours. It was Declan said, oh, if I plug the 0 in, I lose all those x values and I don't have to do it. So, in our problem, it ended with a -4. So 0, -4 happened to be one of our ordered pairs. But just like in a linear function, that last value, that constant on the end there, whatever it happens to be, will also be an ordered pair. It may or may not be useful for your graph, but it is a possibility if you want to do it. So there's two. We're going to pick one. I'll let you guys decide. Do you want to graph this one or that one? Number one or number two? How many of you are number one? How many of you are number two? All right, I guess we're going with this one. So there's your graph. You can put it in the second opening. You're going to start by finding what? Your axis of symmetry. Find that middle. And of your 5 ordered pairs, it's going into slot number what? Number one? Number 3. You want it to be in the middle. Okay. Opposite of B over 2 times A.
That was my question. This would be positive.
Correct. Yeah, in this case, your B value is already negative. So it's got to turn into a positive. So think about where is my middle going to be? Fill that vertex into the middle spot of your 5, and then build your x values around it. Now it's like ultra important that you get your vertex right. If you miss a sign and you claim the middle to be somewhere other than the middle, now you're building something that's never going to work. So be careful that your signs, nice. Be careful that your signs are what they're supposed to be. Yes. Yes, give me 1 second. What's up? Good. What you got? So that's your middle value right there. So this order pair, 1 and -2, should go right there in the middle.
Right here.
Should go right there where you have that 2, so that you have equal spaces on both sides. So erase all your x values because you're going to need to adjust them by 1. Put this one in the middle. So there's your middle x value. There's its result. Okay, so smaller, smaller, down here bigger, and bigger. There you go. Now, because you have this one in the middle, these 2 answers here will match on either side. Those 2 answers. Plug, just like you found this one. Take those values and plug them in. Your vertex has to be the ordered pair 1, comma, something. Anybody have the something for me? James? Good. -2. So if I slide all the way down here to wherever my graph is going to be, I know right now that the ordered pair 1, -2 has to go in the middle. It's your vertex. Build around it. Absolutely. Now, start to take those values and figure out what the results are. So you could literally just go back and change those numbers from a 1 to something. I mean, one of these numbers over here, and get the result that goes with it. I'm about to have 5 ordered pairs. How many do I really need to find? Do I have to find all 5? I found 1 so far. How many more do I really have to find? You know, Faith?
You just need to find the vertex and then 2 more.
Just 2 more.
And that's like the one above it, and then 2 on the
Okay. So what x value am I putting directly above the vertex here? Put a 0 here. And the next one above that? -1. And below the vertex, I'm putting a 2 and a 3. Okay. Of these choices, which one's the easiest to find? Right? The 0. If you put a 0 into that entire equation, what do you get? You get 1. If I know that answer, what else do I know? I know the one on the other side of it. If I'd plug in a 2, I'd get the same answer. So I haven't done a whole lot of work at this point, and I'm almost done. Make a choice. Either you're plugging in -1 or you're plugging in +3. Whichever one of those two you feel like is easier to graph. James, what did you get for a result of that? Oh, okay. So what did you do it? Not yet. What happens when you square a -1? Positive, yeah. So it becomes not -3 as a result. It becomes +3 plus 6 plus 1. Total of 10. So that number's a 10. That number's a 10. Okay? So at that point, then, it just becomes about graphing it. And that's really what all this said along the way. Like all this, you know, you can find your y-intercept as one of your values if you wanted, right? Find 2 more points along the way that get you there, and you got it. So, start with that axis. Come on, slide down. Start with your axis of symmetry. Find the vertex. Find the y-intercept if you can. By the way, did I find the y-intercept in this? Y'all, which ordered pair is the y-intercept? Which ordered pair is the y-intercept? No. Han? 0 and 1. Value of y when x is equal to 0. That's a y-intercept. So that was the freebie that I got right there. Found my vertex, found the y-intercept, mirrored it to the other side, just found 1 more point, and I was done. So down 1, or excuse me, 1 and -2. To the right 1 and down 2, there's that one. 0, 1, and 2, 1. There are those two. And then -1 with 10. Now that one would be off your graph a little bit, but you could float that point up there roughly, make that work. Okay, there you go. But it all starts with you being able to figure out where your vertex is first. All right? All right, last question, and we're done. Well, you have homework, but yeah, we're done for class. Okay? So here's the question. Words, everybody loves them. So the height and feet of a basketball thrown could be modeled by that equation there, that function, -16x squared plus 32x. X is the time in seconds after the ball was thrown. I'm looking for the ball's max height, the time it took to get to the max height, and how long was the ball in the air altogether. It's really not. If you just think for a second, about what it is that you're really looking for here and how you want to find it, it really is not going to be that difficult to figure out. Visualize what's happening. I took a ball, I chucked it. It's got to go up. It's got to come back down.
Newton's third law. That's not
Okay.
third law.
I don't even think you need to graph it, to be honest with you.
That's an object in motion stays in motion.
Like gravity.
Maybe it's that one because of the acceleration. No,
Well, the next law is
I know it's not the first one. Maybe the third one.
Man. Listen to you guys arguing about nothing.
I'm working and double tasking.
Like a fig Newton.
Fake news are good. I'm stuck.
You are.
Yep. I want to write down, but it's just gonna be like not that negative.
So f of x stands for a function of x, which, yes, is equivalent to y. I want to find the max height. Where am I going to find that? Yeah. Because when you find the axis of symmetry, what gets found? The vertex. Is that not going to be where you find the ball's max height? In fact, I would say that you're also going to find something else there other than just its max height. Absolutely. James says you're also going to find the time it takes to get to the max height. If you thought about that ball being launched and you found its vertex, and I'd even make one more argument and say you'd find something else. Absolutely. So what's its max height? Oh, I don't agree. That's a negative. Yeah. How long does it take to get there? How long does it take for the ball to reach the ground? At 3 seconds, it's negative 48 feet in the ground. 2 seconds.
I don't understand. I got 4 when I did this one up here. Because it's not 9 minus 6 plus 1.
For
For 1.
this is 3 minus 6 plus 1.
What about the square?
You square a 1, it's still 1.
Oh, okay.
You're not don't multiply those two together first. You have to square the 1 and
Okay.
then multiply it by 3. Yep. Yeah. Well, if you know how long it took to get to its max height, shouldn't you know how long it took for it to get back down?
Maybe
Right?
I do understand.
Yeah. If I use the formula the opposite of b over 2 times a, what is b in this problem? I lost my, there it is. What is b? So I'm putting in negative 32 divided by 2 times a, and a is a negative 16. So the answer to that is what? 1. If you had a table of values, that 1 would go right there. What's the corresponding y value if I'm using the function f of x equals negative 16x squared plus 32x? If I plug that value of 1 in, what's the corresponding value that goes with it? 16. I'd say at this point, you've already answered the first 2 questions. What's the ball's max height? 16. It's the vertex. It's the very top. It can't go any higher than that. How long did it take to get there? James? 1 second. At this point, you've got that one and that one done. And I'd be honest, I think you probably have this one done too if you just stop and think about it for a second. James? Okay, so if one's a halfway point, then you just need one more second to get back down to the ground. So it should be 2 is what it should be. Now, if I finish out this chart by filling in values around the vertex, if you plug a 0 into this equation, you get 0. Essentially saying no time, no height, ball hasn't gone anywhere. It has to have a match on the other side. So the order pair of 2 is also paired with 0. So 2 seconds, the ball also has no height, aka it's back on the ground. If you put either of these values, -1 or 3 in, you're going to get a value that is what? What type of value are you going to get? It's got to be a negative number. The height was 16. The next value down is 0 on either side. The next ones have to be negatives. What are they, though? Declan, you had them, didn't you? Negative what? -48. Okay. Now, in this particular case, both of those values don't make any sense here because the ball can't have negative height. It's not going through the ground, even though some of you might have been blocked so hard that your ball looks like it went into the ground. All right. But it can't really have that. Okay. So even though those values, they're below the x-axis here. All right. But truly, this vertex right here in the middle answered all those things. If I know how long it took to get to the max height and I know what the max height was, then I should also be able to figure out the other side of that. What's up? If the cliff is representing the x-axis or 0, then I would agree. But in this particular case, we're not playing basketball on a cliff, are we? Though I did watch a video of 2 guys playing on like the side of a mountain. It was very interesting. They did not, but I'm like, what happens when you dribble one off your foot? You know what I'm saying? And then game's over. Like that's how we're playing. Or you make somebody go get it. Like I don't know how that works. So, anyways, if you look at the other side of that paper, there are 5 questions there. Okay. Those 5 questions. Sure. Those 5 questions should not take you but a couple minutes at most, I would say. There's one graph in question number 5. The other ones are just simply asking you, maybe about a max height. Where are you going to find a max height at? Okay, at a vertex. All right. I know everybody loves words. And then there also is a form that's in your classroom. So before I see you tomorrow, those are the 2 things you're responsible for. You didn't even have homework last night. Right?